Again, let me introduce myself one more time. So my name is Monchai.K. This is how to spell my name, Monchai.K. So I will be your instructor for calculus two for the second half. Uh, this is the basic summary for our second half of the class. So basically, we are going to meet on Monday from 11 to 12, which is today, and Wednesday 10 to noon. This is the same time as before midterm with Ajahn Tirapong. So the Zoom ID is going to be this one. Well, you're already in, so you know that. Office hours, because this is an online learning. So, well, I don't go to my office often this semester. So if you want to meet me in person, you can send me an email so we can meet in person, and you can also ask me to do office hour online as well. Well, everything you can make an appointment by email. So just email me monchai.k@jula.ac.th. So this is, well, I am very active on the email. So if you email me, so you expect to get your response within 24 hours, I think. So I will reply that. So summary of my background. So in case you're interested, so I got my PhD in applied mathematics. So I start learning math in my bachelor degree, and then well, I got scholarship, something like that, and then I did my graduate school, like master and PhD in applied mathematics with concentration in statistics. So, well, basically next year when you learn probability and statistics, you are very likely to see me again, because that is my expertise. So, well, but this class is calculus. So we are going to learn the calculus for this class. Well, let's relax about this. So I know some of you have a hard time with math. Well, some of you say like calculus is the worst because, they have so many techniques and something, but well, let's start over again. Let's think that this is the new semester. So we are going to learn this thing again, step by step. And well, open your heart, and this should be a good content to learn. So compared to the midterm, we are not going to talk about series again, but uh, after midterm, what are we going to learn? We are going to give you an extension to multivariable calculus, which is different thing compared to before midterm. So if you feel like you did so bad on series, power series, and three-dimensional things, so that's fine. That's fine. You still have a chance to get a good grade. You still have a chance to be successful. Fine. So after midterm, we are going to learn something different. So this is going to be a good time to start over. Well, any questions so far? So today we are not going to learn a lot. So we're going to just, give you an introduction, a chat or something. Well, I would be happy to take your questions. If you have any question, let me know. All right. If you feel like you are afraid to be in public, you can just send me a chat, like private or public, doesn't matter. Sounds good? So far, so good? All right. So if you don't have any question, I will take more steps to talk about our tentative schedules for the remaining of the course. So this is the table for week 9 to week 17. So you can see that in the middle, we have Songkran break, which is a good one. I love the break. So we are not going to give you a lecture on the break for sure. Yeah, break is a break. Let the break be the break. So week 9, so this is today, we are going to start by give you an idea of multivariable calculus. And then after that, on Wednesday, we're going to start learning limits and continuity. And the next week, we are going to learn partial derivative and the chain rule. Well, you can see that the content looks similar to the one you learned in Cal 1. Well, we are going to learn the same thing as in Cal 1, but we are going to just extend the idea into two-dimensional and into two-dimensional vector space. And then after that, we are going to learn how to extend the idea of integration into two dimensions, well, which is going to be week 12, double integrals. And then after that, we are going to wrap up the class with the differential equations. Well, you know what? For you as a BB Tech student, well, you may have a question that why do you have to learn this thing? So, well, I will let you know that, well, I believe that for all of you, maybe only 5% of you or 10% of you, you will have a chance to use this thing in the future. But most of you, like 80 or 90%, you will not have a chance to use calculus in the future because, calculus is the basic thing. It's the basic subject. In real life now, what we are working today, we just use calculus indirectly. What I mean by indirect is just everything has been developed so fast, and then you already have computer, you already have software, you already have everything that you can just click on one click and you get everything done. But we learn this thing as a basic. So, well, only some of you will go into the theory of this thing when you do the research. Well, sometimes when you do the research, you have to go back and look at this thing again, and you just, we just learn it to appreciate the basic, and also we just we don't know what we are going to see in the future, so we just learn the basic first, but don't expect that the reality it's going to be hard like this, because in reality now you can just we have software, we have internet, we have Google. Why do we have, it's going to be easy in your real life, but here, well, this is the challenge one, because you are going to learn the theory, the background, the thing behind the software that you use in real life. Does it make sense? Well, compared to your to yours. So I will give you an idea that, well, I have a background in math. Well, on my first year, like you, I hate biology so much because, I am good at calculation, I'm good at math, I hate biology. But, well, when I went to America, like in 2012, and then 3 years after, I failed. I failed in my probability research. So I have to switch myself to do biostatistics. And at that time, my advisor was like, Monchai, you have to learn biology 101 again. Because at that time, when I was like 27 years, I think at the time at 26 or 27, well, I had completely forgot the biology 101. And then, well, my advisor said that, well, if I don't know biology, I cannot talk with people in the real world, because to be success in biostatistics, I need to communicate with biologists. So I was sent to learn biology 101 again. At that time, I don't know what DNA is, what is ATGC, the protein foldings, what is genotype, what is phenotype, I don't know. So, well, this is the example that you don't know what are you going to face in the future. Like you learn calculus today, maybe you will not use it like in 4 or 5 years now, but maybe in the future at some point of time, you will be asked to learn calculus again for some project or something like that. So at that time, you will be happy that you learn this thing, and then you can get back to this content fast. Well, I talk so much already, but if you have any question, let me know then, so we can chat more. If you want, email me if you need me to answer something. So let's talk more about the cost evaluation. So this is going to be the one that you I think all of you are most interested in this thing. So for cost evaluation, so with Ajahn Tirapong, you already did 50%. So for my part, we are going to do another 50%. So from course syllabus, we said that we're gonna have the final exam for 40%. So we're gonna keep the final exam 40%. Well, expected to be in class final exam. Well, we'll see how it's go in May. Well, if if the COVID situation is getting better, maybe they're gonna let you take an exam on site. That would be good. So that's for final exam. But well, you never know again. So maybe in 2 months, well, we will follow the rules from the Faculty of Science. Well, another 10%, this is going to be the take-home quizzes. So, well, we state in the syllabus that we're going to have quizzes, but to just give you more relaxation. So I don't want to give you a quiz like in class. So we're going to give you take-home quizzes. So we're going to have two take-home quiz. Quiz 1 will be about March 31st to April 2nd. So at that time, we will be done with partial derivative. So we can give you a quiz 1 on everything from today up to partial derivative. I think that will be the quiz 1. So quiz 2 will be the double integration. So which is going to be the last week of April. Well, when it gets closer to that week, I will send out the rules again. But usually for the take-home quiz, I will send you a quiz. You are expected to do like, I think 3 or 4 questions. And then after that, you submit back to me. And then we grade it and give you a feedback. For quiz 1 and quiz 2, you are expected to get high score. So I expect that everyone should get quiz 1 and quiz 2 more than 80% because they will be easy. They will be the one that you just need to practice a lot. So if you get quiz less than 80%, that would be bad for you because quiz is easy for me. I mean, quiz is the part that I am trying to help you. Any question on that thing? Well, let me know if you have any questions. So I want participation. So if you speak up, so I would be so happy. Does it make sense? All right. Any questions so far about the format of the class or anything you want to know about me or this class? Anything? I'll give you a minute to ask. No. Okay. Thank you. Well, thank you. Thank you. Thank you for those of you who answer. Are you going to record this Zoom meeting? Good question. Thank you for that, Cream. So I will post the lecture video after class on my YouTube channel. So if you miss something, you can always go back to my YouTube channel and look at some content. Well, sometimes if I don't have time, I will give you more examples where the clip in my YouTube channel. So sometimes I will say, hey, this example is so easy. So I will give you as an exercise. And then if you want to check the answer, just go back to my YouTube channel and then you can check the answer. All right. Well, I am now getting some direct message. So I'm gonna answer the question first. So one student asked me, are you going to check the attendance? So the answer is no. So no score for attendance, but well, you know what? If you choose to skip class, well, you're gonna have a hard time to follow up the lecture because the best way to learn is you just attend the lecture class because if you procrastinate to attend and then you just want to look at the clip just 1 week before the exam, well, it's going to be heavy on that week and you will see that you will not be successful in this class. Usually people who skip class get below B or C plus for sure. Well, I mean, that's my experience. Well, unless you feel like you you are expert. Well, show me the expert thing, and then I can give you A. But usually I do expect everyone to attend class, and I'm so happy and thank you everyone to attend my class. Well, even no attendance, but well, it's make me happy, and it's makes the class more lively when you have more students. All right. Another question is, do you have any textbook recommendation for this class? So the textbook's gonna be the one that we always use, which is Stewart, Calculus by Stewart. So I can send. Well, I will post the book. Well, but this should be discreet though, because the publisher is going to be getting mad if they know that we just send out the PDF file. So, but I am going to post the book that we use as a reference in the Blackboard. So you can download from there. All right. Anything else? All right, just chilling for today. So sounds good. Sounds good, everyone. So let me move on to the review first. So I will give you an idea what are we going to learn from now on. So you can see, don't be scared about what are we going to learn next. So first of all, let me review something for you. So you can remember that from calculus 1, what you learn is the heart of calculus. The thing that you learn from Cal 1 is limit, is continuity, is differentiation, and integration, right? So you have 4 things that you keep doing this thing again and again and again in calculus, right? From Cal 1, you learn how to compute limit. You learn to check the continuous function. You learn how to differentiate. You learn how to integrate. So for example, if you have the function fx equal to that, this is the function fx equal to x cubed minus 2x squared minus x plus 2. So if you have that fx, I will start from the easiest one. So this is the function that you learn in Cal 1, for example. So we learn how to find limit. If I ask you to compute limit of fx when x go to 1, for example, so I expect that everyone know how to compute this limit. So you're going to say, hey, Ajahn, this is so easy. So we are going to just compute the limit. X go to 1 of this, right? X cubed minus 2x squared minus x plus 2. So that's mean I can use the property of continuous function and plug in number 1 here. Plug in number 1 here. So, and then you compute, this is 1 minus 2 minus 1 plus 2. And this is actually 0, I think. Well, I'm slow in computation. So 1 minus 2 minus 1 plus 2. Yes, this is 0. And then you can see, hey, this is actually 0, which is a good one. Well, the idea after today is on Wednesday, we are going to learn how to compute limit in 2 dimensions, which is going to be the extension of this thing. So, and also from Cal 1, you learn how to differentiate. This is the part that you compute limit, right? So you also learn the part that you are going to differentiate. So everyone know the formula, how to differentiate, right? So if you have f that one, so you can differentiate f prime x, and that will be 3x squared minus 4x, right? 4x minus 1. So this is how you differentiate this thing. And then how to integrate. If you want to integrate, so you can integrate fx dx. Let's say I want to integrate from, let's say 0 to 1. So what I'm going to do is I'm going to integrate that function x cubed minus 2x squared minus x plus 2 dx, right? From 0 to 1. And then I can say, hey, this is x to the 4th power over 4 minus 2 x cubed over 3 minus x squared over 2 plus 2x, and then evaluate at 1 minus evaluate at 0. And you can keep going, and that would be your answer. Well, I will do that. 1 over 4 minus 2/3 minus 1/2 plus 2. Well, I will leave you to add this thing by yourself. But that is how you find limit, differentiation, and integration for one dimension. But after midterm, what are we going to do is we are going to give you an extension. So we are not going to talk about one dimension. We are going to talk about what if we have two dimension? What if you have fxy two dimension? So this is going to be getting closer into your real life, because in your real life, when you do the experiment, sometimes you just use more than one variable, right? Just in case, for example, you let's say you do an experiment and you wanna, well, you have so many factors that you expect this is going to be the factor that affect to the height of the, you know, the plant or something. Well, you could have so many factors, like you have the sunshine factor, or you're gonna have the water or the soil or anything. So that means you can have more than one factor that affect to your function. So that would be best to model it by using multivariable calculus. So we're gonna give you the idea from now on. You know, in 6 or 7 weeks, we're gonna learn how to do that. All right. So for today, what I think we have about 20 or 25 minutes more. So we are going to give you an idea about multivariable calculus. So let's start talking by looking at the function of two variables. For function of two variables, so you can see that the different thing now is you can have more than one variable in your domain. So before you're gonna have y equal to fx, this is called a single variable case, right? So you send x to y, but because now you have function of two variable, so your domain gonna be something that you have an order pair x, y. So you're gonna have to input in your domain, and then you're gonna send this thing to some value in the range. So because we already use x and y as variables in our domain. So for the range, we are going to use another notation, which is c. This is c, right? Well, I express this thing as an American accent, so c. Well, x, y is in your domain. You're gonna send the function to c. So for example, let's look at example one. Well, I would say that, so example one, this is the basic one. So find and sketch the domain of the following functions and then compute f11. So when you have like example 1.1, so you have fxy equal to square root 6 minus x squared minus y squared. All right, for here, so you can see that we're gonna find the domain of this thing. So the domain of this function means you need to find all possible value of x and y that you can plug into that function, right? Domain means all possible values of x and y. This is the same thing with the domain in one dimension, but here now you treat it as an order pair, so you're gonna have all possible value of x and y. So you have to figure out what are possible value of x and y. So we're gonna use the same trick as you learn, you know, in high school or before. So under the square root sign, you must have something positive. I should say non-negative. So under square root sign, you need to have something that is non-negative. So that means if you have square root something, the box under square root sign, this must be positive. Well, this is a trick. If you see square root that thing, so it must be the case that your box over there must be greater than or equal to 0, right? Because the thing under square root sign cannot be negative. Well, that means for this case, your domain gonna be set of all the pair x, y such that 6 minus x minus x square, sorry, 6 minus x square minus y square is greater than or equal to 0. So this is going to be your domain. And then, well, we can simplify a little bit. So this is going to be set of all x, y such that x square plus y square less than or equal to 6. So you can simplify, but just move one thing to the right hand side and move, just move around, and then you're gonna get x squared plus y squared less than or equal to 6, which means the domain, if you graph it, so this is a graph of circle, right? X squared plus y squared less than or equal to 6. This is a graph of the circle. So you're gonna have the circle here, and then everything inside the circle, this is going to be your domain. So the domain is going to be any point inside the circle with radius equal to square root 6, right? Because this is the standard circle with radius. The center is at the origin 0, 0, and the radius is equal to square root 6 because you have 6 here, which is give you the radius square root 6. So any point inside the circle will be your domain. So every time when you plug in the function like f11, the question asks you to do f11. If you want to plug in 1 here, it's going to be square root 6 minus 1 minus 1, right? 1 square here. And that will be square root 4, and that is 2. So this is how I give you this example to show you the idea of function of two variables. That, hey, this is called the function of two variables. You can find the domain. And then every point in the domain you can plug in, and then after that you're gonna get the function, the value of the fxy. In this case, f11 is 2. So the thing that we're gonna learn on Wednesday, the next class, is what if I ask you to compute limit? You know what? If I want you to compute limit, so before you're gonna say limit when x go to something, right? But here, because you have 2 dimensions, so it's gonna be limit x, y go to something. It is not going to be just in 1 dimension, because in 1 dimension, let's look at that. In 1 dimension, you have, let's say you want limit go to 0. So on calculus 1, you have left hand limit and you have right hand limit, right? Left hand limit and right hand limit, and you say, hey, Ajahn, if left hand limit and right hand limit, they are equal to each other, then limit exists and blah, blah, blah. That is in Cal 1. But you can see that now your world is different because you have the point in 2 dimensions. Let's say this is a point question mark in 2 dimensions. So you're gonna have left hand limit, you're gonna have right hand limit, you're gonna have up hand limit, you're gonna have down hand, you're gonna have, oh my God, any single line that you can have so many, infinitely many lines that can go to that point. How would I compute the limit for this case? That is what we're going to learn on Wednesday. How do we define limit? And also, if I have fxy here, which is the function square root 6 minus x squared minus y squared, how I differentiate it? Well, in 1 dimension, you say f prime x here, which is you learn the formula how to differentiate it. But here you have 2 variables. You have x and y together. Well, how can I differentiate this thing? Well, the notation gonna be, well, you have to differentiate with respect to x, or you have to differentiate with respect to y. We're gonna give you step by step how to define it and how to compute it. Does it make sense? Does it make sense? And then also the last one is the hardest one. So you used to integrate fx dx here, but for this class, we're gonna give you how to integrate in 2 dimensions, which is going to call double integration. Well, don't freak out now because, we are going to learn step by step, and I promise you, I will go slow for you. And if the content is so much harder than what you need to know, I will cut it off. So I will just teach you only the thing that you need to know and you can carry for your future career. I promise. So the thing that is way too hard, I will not just dig into that thing because it is ridiculous that you learn something harder than what you need. All right. Well, we're gonna just stop talking about limit, continuity, differentiation, and integration for now. So we're gonna do example 1.2 first. Sorry, I keep keep chatting outside the content. All right, so let's do example 1.2. One more thing. So let's look at the function of logarithm. So you have logarithm function here. So the trick for the function logarithm is here. So if you see logarithm of that in the box, so the idea is it must be the case that what? So for logarithm, after logarithm, that thing must be positive. That thing must be positive. Is that okay? Because the thing is that when you graph the log x, well, you can see that your domain of log x is going to be positive. So the graph here going to be on the positive side of x. So you never touch the negative side of x because that is not in your domain. So because that means every time when you see log of something, the thing after log must be strictly positive. Which mean what? Which mean for this question you have that. So your domain gonna be, well, what is your domain here? So it's gonna be all x, y possible values such that x squared minus y plus 1 bigger than 0. Well, this is going to be your domain because log cannot be negative and cannot be 0 as well. I mean, the domain of log. Well, and then you just simplify a little bit. So, well, some of you are gonna have a hard time to simplify, I know, but well, let's say that I'm gonna keep x squared minus 1 here, plus 1 here, and then I move y to the right hand side. So I add y on both sides, and then you have y less than x squared plus 1. So to graph this thing, so you need to say, hey, this is y, this is x, and then y less than x squared plus 1. So that means you have to graph y equal to x squared plus 1 first, right? And then you can just shade the region after. So what is y equal to x squared plus 1? So y equal to x squared is parabola. Y equal to x squared plus 1 is also parabola, but you move up, shift up 1 unit. So this is going to be your line, y equal to x plus 1, if my scale here is 1. So that means this is the line y equal to x squared plus 1. Well, you can observe that I do the dashed line because this is strictly greater than. Well, I will not include the line. So that means I do the dashed line. And then after that, you can see that, hey, that is the line y equal to x squared plus 1. But now I need the region that represents y less than x squared plus 1. So which one is y less than x squared plus 1? So if you have a hard time to think, so it must be the green area or the yellow area. It must be one of them. Well, green or yellow, which one represent y less than x squared plus 1? So some of you say yellow. Good, good. If you type in the chat the answer, good one. Yeah. Sarat, yeah, Sarat, yeah, say yellow. So, well, let's check if yellow is the correct one. So you can pick any point. If you pick any point in the yellow area and then you plug in the value, if it is good, then, well, your guess is correct, right? So I am going to pick just one point. Maybe I pick x equal to 0, y equal to -1. And if I plug in into the domain, yes, it is valid. So that means the area that I want is the area on the yellow shape here. Does it make sense? So the green one, this is not what I want because we want y less than x squared plus 1. Sounds good. So the idea for today, I just want to give you more comfortable with two-dimension function. You know what? Because on Wednesday, we're gonna start talking about limit. Well, today just make sure you're comfortable with two-dimensional function. One thing is that well, you keep in mind that the two-dimensional function here, it is not easy to graph. It is not easy to graph because you can see that when you what you learned before when you do a y equal to fx, so you can graph it because you have x in one dimension, you have y in another dimension, so your graph is going to be in two dimension, right? And then you can graph x, y, super easy, right? Square root x is just that, done. But in two dimension, you can see that your domain contains two variable x and y, right? And then to graph it, you need another axis, which is going to be c axis. So here you're gonna plot on the x axis, here you're gonna plot on the y axis, and also you need c axis as well, because that is going to be your value c equal to fxy. So the plot for two-dimensional function, this is going to be in three dimension, because your domain gonna be x and y. X, the thing that I highlight draw in green now, and y here, this is going to be your domain, because domain is here, right? Wow, that's a lot. But you need another dimension for c as well, so the plot gonna be three dimension, well, which is usually hard to plot it by hand. So keep in mind that the geometric interpretation of two-dimensional function, this is a surface. It's going to be a surface. This is not a line. Well, it is hard to graph it by hand. So if you need to graph it, I would recommend you to use a software or computer in real life as well. So you can use the software and computer, why not, right? Look at this one, sine x plus sine y. Who's gonna graph it by hand? No way. If you ask me to graph it by hand, I will not do that, right? Sine x times sine y over xy, the graph it like that. So we're not going to do it by hand. So I would say in real life, you would need a software for sure. For sure. Well, I will not teach you to graph that by hand because, as a mathematician, I'm not going to do it by hand too. Well, if the function is easy enough, you can do it. You can do it. Well, only if the function is easy. Well, I will show you how to do that in example 2. This is going to be the easy case that you can graph it by hand, but usually do not do it because it's terrible to do it by hand. Well, we're gonna have about 10 minutes left, I think, for this class. So I'm gonna show you example 2, and then I'm gonna stop. I am going to stop the lecture. And on Wednesday, we are going to talk about limit and continuity. So this is going to be our last example for today. Sounds good? All right, this is the big one, the long example. So one more thing that I want to let you know is if you want to chat with me, so just you can chat in public. You don't have to private message because you don't have to be shy, because so when you ask something, your friends know and then they learn from it too, because some of you are very shy and you never ask something. So you have to change your behavior now. So let's trying to make the class more lively by asking questions. Well, I'm more than happy to answer your question, because if you ask, I know that you have a hard time and I can go slower and then I can explain more for you. Because if you don't ask, I don't know that you are in trouble, and then I can keep going, and that will be fast, and the exam going to be harder that way too, because I assume that everyone understand. So if you stop me from time to time, I understand that, hey, okay, student have a hard time, so I need to decrease the difficulty a little bit or something like that. All right, so let's look at example 2. This will not cover, for example 2, this will not be on the exam or quiz, but I just want to give you the idea how to graph it. But I will say that here, this will not be covered on the quiz or the exam. So to graph the two-dimensional function, I will not ask you to do it on the quiz or exam, but I just want to give you the idea for, for the future thing for you. So suppose the function is easy like that. How do I graph it? So the function here is going to be c equal to x squared plus y squared, right? Well, I replace fxy by c. Well, in order to graph this thing, if you have to graph it by hand, so the best way to do is you just fix. So I'm going to fix c equal to 0 first. If c equal to 0, you can see that 0 equal to x squared plus y squared. So this is going to be just the point 0, 0, right? Because x squared plus y squared equal to 0. If you solve that equation, the only point that satisfies that equation is 0, 0. Well, let's say if I fix c equal to 1, then what happened is 1 equal to x squared plus y squared. Well, if you are expert in geometry, you can see that this is circle with radius 1. Right? This is circle with radius 1. The center at 0. Center at 0, 0. Well, that is when c equal to 1. Well, when c equal to 2, so this is going to be 2 equal to x squared plus y squared. Well, the same pattern repeat. So you're going to have a circle again, but this is with radius square root 2, right? Because your constant are different. So this is the radius square root 2, center at 0, 0. Well, fine. Well, if I move more steps, c equal to 4, then 4 equal to x squared plus y squared. And then this is always circle, right? With radius equal to 2. Square root 4 is 2, right? And center at 0, 0. So if you actually need to graph it, c, x, y. So you can see that it will be in 3 dimensions, right? And then when c equal to 0, it's mean at this plane, c equal to 0, c equal to 0. So you just have a point 0, 0. And then you plug in c equal to 0 as well. So when you have c equal to 1, this is when c equal to 1. You're going to have a circle with radius 1, center at 0, 0. So actually you have a circle here with radius 1. Well, when c equal to 2, so you also have a circle, but now center is the radius is square root 2. So you're going to have a circle at the same center, but your radius is just getting bigger. This is when c equal to 2. When c equal to 4, so you're going to have the same pattern, circle, but the radius just getting bigger. So you're going to have that. Beautiful. And then now you can see that, well, the behavior of c, they always give you the circle if c is positive, right? The only thing that you need is, well, you can connect this thing. Once you connect this thing, you're going to get a picture like a surface. So I'll give you the answer now. So if you connect this thing, well, it could be the cone or it could be the paraboloid here. Well, we don't know yet that it's going to be the cone or it's going to be something like the bowl. So this is form we fix c. So let's try to fix another variable. So let's suppose I fix y. So let's fix y equal to 0. So what is going to be the case with if I fix y equal to 0? Then this is going to be c equal to x squared, right? So this is going to be parabola in terms of x and c. So that's mean when you draw the picture. So if you fix y equal to 0, so you use the y plane to cut, so you're going to get the parabola. So this means this is not a cone. This is going to be a bowl. So your graph is going to be the bowl. Well, my scale is not good. That's why you can see here. Okay, I'm going to extend my my circle here. All right, did you see that? So every time when you cut like the with the c-axis, so you're gonna get the circle. But if you cut with the y-axis, like perpendicular, so you're gonna get parabola. So this is how you graph the function of two variables by hand. So you can see that this is not easy. And at the end, you're gonna get this shape. This is a bowl shape. This is called paraboloid in general. So you can see that this is not easy to graph it by hand. Even the function x squared plus y squared, this is the easy one, but you still just need maybe 5 to 10 minutes to graph this thing. So that is why I told you that in real life, if you want to graph something, try to use a computer. So for sine x plus sine y here, I'm not trying to fix c and then just look at the behavior and then trying to connect the geometric plane or something. That would be terrible. So I'm going to use the software to do it in real life. But hey, this is a good example though. It gives you the idea that, well, you can also graph it if need by hand. All right, that is the end of this example. So again, on Wednesday, so you come back to learn limits and continuity. We're gonna talk about that thing in deep, and hopefully you enjoy the lecture. All right, so any questions? So we have I think about 5 minutes left. Any question in general for me and for the class? Well, before you go, so let me stop share this thing, and I know that with Ajahn Guk Thirapong, you barely use Blackboard, but I just want you to get more involved by using Blackboard. I will share the screen. Well, if you go to Blackboard, you're gonna see something like this, right? And you're gonna see our class, which is, whoa, 1 second. Ooh. No, okay, here. So, well, I have so many class with me now, but well, for your portal, you're gonna see one Blackboard class here, right? And then you can click on 2301, 108. This is the Calculus 2 class. So once you click on it, you can see that this is a link to my YouTube channel. So you can go to my YouTube channel here to follow the past lecture. And well, if you click on it, it's gonna link to the playlist for the Calculus 2 BB Tech lecture, which is empty now. And the video for today gonna be in that playlist. Like, well, expect in 1 or 2 days. And then after that, this is going to be the handout. Well, if you lost my PDF file, you can download from here. And I think that for the quiz, I expect you to submit via Blackboard. So I'm gonna just let you know again in when the time is closer. But that is my attention. All right. So if you never check Blackboard out, just check it. You know, it's a good platform to, you know, to just leave the file there and then you can download the file from there. You know, but we are not going to do the exam on Blackboard. This is way too complicated. But yeah, so you can find my YouTube link and my PDF file here. All right. So any more question in general before I let you go today? Oh, where's my chat? All right, sounds good. All right, then. Well, class dismissed. Good. All right. Bye. Or you have any question, you can go. Thank you.
Thank you.